IP Tech Talk. Hello everyone, and welcome to IP Tech Talk. Today, we're going to talk about Wi-Fi 6. We're all very familiar with the term Wi-Fi. For example, every time we arrive somewhere new, one of the first things we do is ask for the Wi-Fi password. And with the development of Wi-Fi technologies, we've now reached its 6th generation, Wi-Fi 6. But first, what is Wi-Fi 6? Today, Wi-Fi 6 is the most advanced WLAN standard, with a speed of up to 9.6 gigabit per second. Wi-Fi 6 was named by the IEEE 802.11 working group, which is responsible for formulating Wi-Fi standards. In 1997, this working group released the first Wi-Fi standard, 802.11. Over the past 20 years, it has released a series of Wi-Fi standards, starting with 802.11a through to 802.11b, G, N, AC, and most recently, AX. Naming the standards like this using digits and letters makes them hard to remember and to widely promote. This is similar to how cellular mobile communications technologies have names such as GSM, CDMA, WCDMA, TD-SCDMA, and LTE, which are equally hard to remember. With cellular, however, these technologies are also named 1G, 2G, 3G, and 4G, which are much easier to remember and understand. Even if you have no related technical knowledge, you can figure out that a larger number represents a more advanced technology. So, in 2018, the Wi-Fi Alliance decided to adopt a new naming convention, similar to that of cellular technologies, and renamed 802.11n, AC, and AX as Wi-Fi 4, 5, and 6, respectively. Note that only Wi-Fi 4, 5, and 6 are recognized by the Wi-Fi Alliance. Wi-Fi 1, 2, and 3 are unofficial names. For convenience, many vendors and industry insiders refer to the Wi-Fi standards prior to 802.11n as Wi-Fi 1, Wi-Fi 2, and Wi-Fi 3. Now, I think it's important to clarify the relationship between WLAN, Wi-Fi, and 802.11. Some people may consider them the same, but actually, there are some differences between them. First, WLAN is a concept that can be compared alongside wired LAN. That is, any communication technology that uses wireless electromagnetic waves as transmission media on a LAN is a WLAN technology. Initially, WLAN technology was proposed to overcome the lack of mobility for users on wired LANs. On a WLAN, users no longer need to access the network through Ethernet cables and can move about freely while staying connected. Next is 802.11. It is the name of a working group as well as a general name of a collection of WLAN communication standards. Besides 802.11 standards, WLAN standards also include Bluetooth and Zigbee, for example. Okay, and what about the term Wi-Fi? 802.11 protocols focus on theoretical design, but there are still some practical issues that need to be resolved in actual production environments. Such issues include vendor compatibility and standard tests over products from different vendors. To resolve these issues, some well-known vendors in the industry jointly established an industry alliance in 1999. The alliance was named WECA, short for Wireless Ethernet Compatibility Alliance. But later they decided this name didn't really have a ring to it, so they renamed it the Wi-Fi Alliance, which became a registered trademark. In practice, the 802.11 working group is only responsible for formulating technical standards, while the Wi-Fi Alliance tests and verifies whether products from different vendors comply with these standards. If they do, the products are certified with a Wi-Fi logo. As Wi-Fi certified products are now so widespread in the WLAN field, both Wi-Fi and 802.11 are now often used interchangeably with WLAN. Through joint promotion by the 802.11 working group and Wi-Fi Alliance, the WLAN industry is embracing rapid transformations. Every 4 to 5 years, the industry will undergo a technological revolution and generate a new generation technical standard. Next, I'm going to share some stories about Wi-Fi standards. When talking about Wi-Fi, we have to mention someone called Vic Hayes. He made pioneering proposals to IEEE to establish a set of international WLAN communication standards. Under his proposal, IEEE established the renowned 802.11 working group in 1990. This working group was chaired by Vic Hayes, who presided over the formulation of 802.11 standards. His outstanding contributions to the Wi-Fi field have led to him being referred to by some as the father of Wi-Fi. The first Wi-Fi standard was called 802.11. Released in 1997, 802.11 works on the 2.4 GHz band and provides a maximum speed of 2 megabits per second. This standard was not put into use at scale due to slow data transmission. Despite that, this standard means a lot to the Wi-Fi field because it signifies the beginning of WLAN standardization. In addition, it transformed how we access the LAN and overcame our reliance on Ethernet cables. Next, let's look at 802.11a and 802.11b. These two standards were formulated almost at the same time, and both were officially released in 1999. However, they would take remarkably different paths. 802.11b, despite being relatively backward technologically, became widely used throughout the market. This is because the industry chain for 802.11a was not mature enough. And once it reached maturity, the market was already dominated by 802.11b. In fact, the majority of users first got to know Wi-Fi starting from 802.11b, with early Wi-Fi capable laptops complying with this standard. Since 1999, laptops from mainstream vendors have been equipped with Wi-Fi and so have mainstream operating systems. So, Wi-Fi's application scope extends from home networks to enterprise campus networks, penetrating every walk of our daily lives. 802.11b is the first major milestone in the development of Wi-Fi technologies. This is why the industry refers to 802.11b as Wi-Fi 1. Let's now talk about Wi-Fi 3, or 802.11g, which was released in 2003. Once nearly all laptops became Wi-Fi capable, it was found that the original 11 megabit per second network access speed was no longer enough. So, to speed up network access, IEEE released 802.11g in 2003. This standard combines the best of 802.11a and b. Like 802.11b, it can work on the 2.4 GHz band, while like 802.11a, it supports OFDM technology and provides a speed of up to 54 megabit per second. With these strengths, 802.11g perfectly met Wi-Fi needs for laptops, and soon Wi-Fi became a must-have for all laptops. Along with the emergence of home routers, this period saw Wi-Fi start to develop at an astonishing rate. Next up is Wi-Fi 4, or 802.11n, which was released in 2009. The year 2007 was a turning point in the mobile phone industry, with traditional feature phones rapidly being replaced with smartphones. This can be seen as the point when the mobile internet really began to develop rapidly, which imposed much higher requirements on the WLAN technologies. 802.11a and 802.11g were no longer up to the task. In response, IEEE released 802.11n in 2009, which increases the speed to 600 megabits per second. This standard is another milestone for Wi-Fi evolution. This is because it introduces several advanced technologies. For example, it begins to work on both the 2.4 GHz and 5 GHz bands, and support technologies such as MIMO, beamforming, and channel bonding. We've now reached Wi-Fi 5, or 802.11ac. The explosion of smart terminals further boosted the mobile internet, as well as Wi-Fi technologies, and this is where 802.11ac comes in. This standard further improves Wi-Fi network throughput. It supports 4 spatial streams and 80 MHz frequency bandwidth, achieving a speed of up to 1.73 gigabit per second. One slight drawback, however, is that 802.11ac supports only 5 GHz terminals, which degrades user experience on the 2.4 GHz band. Another point is that 802.11ac supports MU-MIMO only in the downlink direction, and therefore struggles in the high-density access scenarios. Okay, we've finally come to Wi-Fi 6, or 802.11ax. We can look at the evolution from Wi-Fi 1 to Wi-Fi 5 as a series of incremental improvements to the original 802.11 standard. Wi-Fi 6, however, is a game changer. Wi-Fi 6 is designed especially for the Internet of Everything, and so its core mission is to significantly relieve network congestion and improve the wireless transmission speed and signal coverage range in high-density environments. So, you can see its core mission is different to that of previous Wi-Fi standards. To fulfill its mission, Wi-Fi 6 adopts an array of key technologies from 5G, such as DLUL, MU-MIMO, OFDMA, 1024 QAM, BSS colouring, and TWT. Built on these cutting-edge technologies, Wi-Fi 6 features high bandwidth, low latency, and high concurrency, and lays a solid foundation for digital transformation of next-generation enterprises, HD video conferencing, and industrial intelligence. Before we wrap things up, let's have a look at Huawei's contributions to the development of the Wi-Fi 6 industry. To start with, Huawei actively participates in the work of the 802.11 working group and plays a vital role in the group thanks to its expertise in the wireless communication field. In particular, Huawei experts Dr. Osama Abdul Magd and Edward Au are the chairs of different 802.11 working groups. Dr. Osama Abdul Magd was re-elected chair of the Wi-Fi 6 working group due to his outstanding performance in the formulation of Wi-Fi 5 standards. In addition, Huawei has a Wi-Fi 6 standards formulation team consisting of 15 Wi-Fi experts. The team has submitted a total of 299 standards proposals, accounting for 15% of all Wi-Fi 6 proposals.
So Huawei is a recognized leader in terms of 5G. What's their contribution, though, in Wi-Fi?
Yes, so when we started the project Wi-Fi 6, Huawei was one of the leaders actually in defining the project scope and what objectives need to be satisfied, and we continue actually participating in Wi-Fi 6 and leading the process as well. So we have about 240 submissions actually to the committee working on Wi-Fi 6, and these submissions actually cover all aspects of the standards like OFDMA, it covers special reuse, it covers extended range, so it covers many aspects of the standards. And many of these proposals actually found its way into the draft standards as well. So Huawei actually has very significant contribution during the development of Wi-Fi 6 standard.
Huawei joined the Wi-Fi Alliance in 2011 and became one of the 15 core members of the board. Huawei launched the industry's first commercial Wi-Fi 6 product as early as September 2017 and successfully put Wi-Fi 6 into large-scale use in the Bund in Shanghai, China in September 2018. In February this year, Huawei launched its series of brand new AirEngine Wi-Fi 6 products. The flagship product, AirEngine 8760, provides an air interface rate of up to 10.75 gigabits per second, setting a new benchmark for Wi-Fi 6 performance in the industry. Unlike other Wi-Fi 6 products in the industry, Huawei AirEngine Wi-Fi 6 products integrate Huawei's cutting-edge technologies in 5G and AI, and are ideal for building a fully wireless, high-quality campus network for enterprise office, production, and public service scenarios. Well, that brings us to the end of today's IP Tech Talk about Wi-Fi 6. Thanks for watching, and see you next time.